Good morning, everybody, and welcome to today's webinar on the GE-Statoil Innovative Sand and Water Technologies and Onshore Operations Grand Challenge, the Phase 2, which is Reduced Use of Water in Onshore Operations. My name is Casey Shapiro, and I will be your host and moderator for this webinar. So at this time, we're going to briefly go through the agenda for this webinar. First, we're going to provide the speaker introductions, then we'll provide an overview of the challenge. After that, we'll present the frequently asked questions of the challenge and then work through the live audience Q&A. Thank you so much. Okay, so I believe we got through the agenda slide, and I'll go ahead and go back to our introductions of the speakers, and then we can just push through, and I apologize for that technical difficulty. So, again, I want to reiterate that I'm pleased to welcome the following speakers to our webinar this morning. From GE, we have Diane Finkhausen, Director, Open Innovation and Advanced Manufacturing. And we have Ed Steele, Water Technical Manager, GE Global Research Center, Oil and Gas Technology Center. Then from Statoil, we have Cecilia Nygaard, Principal Researcher, Shale, Oil and Gas Research, Statoil, ASA. And then from NineSigma, we have Al Malouf, Senior Program Manager. So the topic of today's webinar is the GE-Statoil Innovative Sand and Water Technologies for Onshore Operations Grand Challenge. It's the topic 2, reducing the use of water in onshore operations. NineSigma, representing the General Electric Company and Statoil, invites proposals for innovative technologies to use less fresh water for the production of oil and gas in onshore operations. So now we're going to hear from Diane on GE and Statoil's vision for the challenge. Diane, I think you're ready to go.
Yes, great. Thank you. Hello, everyone, and thanks again for joining us today. On behalf of the GE and the Statoil teams, we're really pleased to introduce this initiative to you this morning and to share our collective mission to fuel the future of industry. Earlier this year, GE and Statoil launched the Powering Collaboration Partnership, which is a joint technology investment collaboration that is really aimed at driving industrial response to some of the greatest challenges facing the global energy production industry. And in this partnership, together, we believe that we have an opportunity to lead the industry towards more responsible, efficient energy production solutions. And with that mission in hand, we have today we have launched the next generation in that partnership, and we'll be introducing to you the Grand Challenge, which will solve for technologies in support of this mission to fuel the future of industry. Next page. So this morning, we're going to be introducing the Grand Challenge, which will solve for innovative water technologies in onshore operations. This is a grand challenge that is designed to improve the use of water in onshore operations with the intent to reduce environmental impacts associated with the transportation of water on the local communities and to make energy production much more efficient. In this challenge, and we'll discuss this throughout the course of the webinar today, in this challenge we will be seeking your help with 2 very important topics that we believe will best drive progress towards this mission. The first topic is technologies and methodologies to solve for on-site treatment of produced or used water. The second topic will seek the ability to inject less water downhole during production and or inhibit halite deposition in the pipes associated with these operations. So 2 very unique topics, very important to the industry, and we believe will contribute strong progress towards this mission to improve the use of water in onshore operations. So with us today, we have 2 senior experts from the Statoil and the GE teams that will walk us through more detail related to each of these missions. and will share some of their perspectives and insights regarding the types of solutions and technologies that we're looking for. Thank you.
Thank you, Diane. So yes, so now thank you so much for that overview. We are going to pitch it over to Ed and Cecilia to give us the technical aspects. We will have Ed speak first. So Ed, I believe you are now ready to go.
All right, thank you very much, Casey. I just I'd like to remind people that our overall purpose with this particular challenge is to reduce freshwater use in the oil field. And at the same time, we'd like to be able to reuse and recycle this water with minimal waste disposal. Now, as you can tell from Table 1, the produced water quality varies significantly across the field. And what happens with that, it makes it difficult for one single technology to really treat the water cost effectively. So it's something, it's a key point for people to keep in mind. As Diane stated, this water currently that flows back from the wells as produced water, it's transported by truck to disposal wells. When you transport things by truck, there's always a chance of a spill. And in fact, in just the actual transportation of the water itself, you're having CO2 and hydrocarbon emissions and potential road damage that needs to be fixed. So, from an environmental perspective, if we can have something that works, a treatment technology that can be worked on site at the processing volumes we need, that would be optimal. One thing, if you look here, you can see some of the water, in fact, is very salty. It's actually near the point of crystallization. So if somebody's thinking about crystallizing some of this water, that should actually facilitate such a process. Now, we do understand that the percentage of freshwater recovery may be somewhat low depending upon the overall salinity, but what we'd like from the participants is to quantify that for the range of water quality shown on Table 1, and feel free for any concentrations in between. If you can also quantify how much the percentage fresh water that would be recovered, that would be very useful. I would also let you know that we would be willing to look at some partial desalination. One reason for this is, not all the water necessarily needs to be fresh that's being recycled here. For hydraulic fracturing operations, we could use water that's up to 20,000 parts per million of total dissolved solids. And there's also some other purposes, agriculture or some other potential beneficial uses that the water does not have to be, does not have to meet drinking water standards. So that's something that you may want to consider if you decide to apply for this. The one other item is that it would be beneficial if the proposed technology had a real-time water analysis system to help with treatment optimization and limit over-treatment of waste generation. As we find over the years, the water quality tends to fluctuate over time. And if you've got to treat to whatever the maximum is, then you wind up with more waste, and it's just not as an efficient system. So if you have a smart water treatment system that can deal with this, that would be something we would probably value highly. Next slide, please. Thank you. And again, we're looking to have a treatment system that we can use on site to really minimize transportation cost and the risk and liabilities associated with transporting such water. One of our desires is to minimize the waste products from the water treatment system. We do know from evaluating various systems out there that the type and nature, character, and amount of solid waste or sludge type waste that you might get does vary from different treatment processes, and we would like that to be minimized to the extent possible. Also, energy efficiency is a key for this. If we can have something that's energy efficient, that's going to reduce overall CO2 emissions, and that's also one of our goals of the overall grand challenge. Something that you may consider, it's not absolutely necessary, if you have a process for cost-effectively recovering valuable constituents from the produced water that are marketable at economic levels, that's something we would probably look on favorably. I would tell you, though, that treatment processes that result in hazardous waste products are to be avoided at all costs. That's something we don't want to have to deal with in the field. Also, at the same way, using hazardous chemicals in the treatment process is going to be highly discouraged. The overall treatment economics must be favorable, and the process must meet the volume requirements stated in the challenge. And one last item we mentioned is that novel technologies that are at or near the field demonstration stage will be more highly valued. And that's what I have to say for now. Thank you.
Perfect. Thank you so much, Ed. So now we're going to go ahead and let Cecilia talk on her portion. Cecilia, you should be ready to go.
Yeah, thank you, Casey. I'm going to give you an overview of Focus Area 2, which is all about reducing the amount of freshwater that we inject downhole, and that's in order to prevent halite scale from depositing in the production tubing downhole. So if we look at this slide, I just wanted to give you a short context here. When we hydraulic fracture a well, we normally use quite fresh water quality with a low concentration of total dissolved solids, or TDS as we like to say. But after a while, when the well has been fracked and the water is starting to produce back, it picks up salt from the subsurface. So the concentration of these dissolved solids, or the TDS, can be as high as we saw in Ed's table here, up to 350,000 ppm, or milligrams per liter of TDS, and that's really high. So the problem really occurs when the saline water is being produced back from the bottom of the well to the top side. The temperature drops, and halite will start to precipitate and attach to the tubing, to the production tubing. And we really want to avoid that. So when the salt or the halite precipitates and attaches to the walls of the production tubing, it starts to build up and may eventually cause a blockage that may shut down the well for a period of time, which we want to avoid. And how do we usually fix this? It's usually fixed by injecting amounts of fresh water downhole to dissolve the blockage. We also, in some cases, use scale inhibitors. And for the wells with the halite issues, not all our wells have these issues. In certain areas, the halite is a big issue. But for the wells with these issues, fresh water needs to be injected downhole on a daily basis. And if we think about a well is producing for 20 years, this accumulates to quite large volumes of water that has to be transported in and also either trucked or piped out down to a disposal well. So from an environmental perspective, we want to use less water because this fresh water also has a cost. So to comment on the graph to the right, you can see the graph shows the saturation ratio for 3 different wells here. And the saturation ratio, when this is kind of a number for when the water starts to precipitate salt. So when this is above the pink line or above 1, salt will precipitate. So as I explained to you earlier, as the temperature drops, when the saline water moves up the vertical well, the salt will start to precipitate if the TDS is high enough. And this will of course depend on the water chemistry and also the temperature and the pressure. So downhole, we have seen that this may start as deep down as 4,000 feet below subsurface. And as you can see from the graph, it's that the water chemistry here is a big factor, because as you can see, a difference of about 100,000 ppm TDS will mean that in the two upper wells, the salt will precipitate, and in the lower one, it won't. So the water chemistry and temperature and pressure will be factors that decide the halite precipitation. So if we go on to the next slide. So what do we want to solve and what do we want to achieve? That's the question. And first of all, we don't want the halite to deposit onto the production tubing downhole. And secondly, we want to achieve that goal by other means than the use of large volumes of fresh water. So as you can see, the pictures below here gives you sort of an idea of what we are dealing with. As you can see, it's a thick salt cake which attaches to the tubing. And we are looking for technologies that can be used as an alternative to this freshwater injection. And just to give you an idea of what kind of technologies we are looking for, examples may include, and I'm saying may include because it's not limited to, it could be coatings, it could be mechanical devices that prevent the halite deposition. It could be ultrasonic technologies, electrochemical technologies, electromagnetic that applies some kind of heating, the use of renewable energy, and also additives. But I have to emphasize that the additives should be environmentally friendly and effective in very small doses, as we don't want to increase our chemical use. And any additives in use will have to reduce the water needed substantially. I can also mention that we have already tried commercially available halite inhibitors, so we're really looking for novel chemistry out there. And I can also mention that a combination of these approaches could also be an alternative. So in the end, I want to emphasize that we understand that we cannot remove the salt downhole, but we want to prevent the salt from depositing in our production tubing. So that concludes the technical part of the presentation.
Perfect. Thank you so much, Cecilia. So now we will go ahead and hear from Al from NineSigma about the timeline and evaluation criteria for this challenge.
Good morning. So the challenge has been open since July 7th. And I want to just mention that we have a two-part response template, and I want to encourage you all to go and fill out part one. So part one is just a few check boxes and a short text box. It should take you just a few minutes, and that will help us keep you informed of any events related to the challenge. You can always come back later and fill out part two, which is the bulk of the proposal. And you can do that anytime until the close date. So you can edit your response anytime until the close date, which is September 24th at 5 p.m. Eastern U.S. time. That's really critical, so I'll say it again. The challenge closes September 24th, 5 p.m. Eastern U.S. time, and after that time, you will not be able to submit or revise your application. So that's an important date to keep on your calendar. Following the close date, there'll be several weeks of a very thorough review by the GE and Statoil expert teams and judges. The winners will be announced in November, and we'll broadcast the exact date as soon as it's available. So what are some of the evaluation criteria? So the first is technical maturity or readiness. If you've looked at the challenge website, you know that the sponsors are interested in technologies that can be commercialized within 1 to 5 years. And the reason for that is they want to really encourage technologies and support technologies that will make a difference in the short term. They want to make an impact on the industry. Second criterion is the performance criteria, of course. So how well does your technology address the technical issues that are described in the challenge statement? Third is the ability to commercialize the technology. And what we mean by this is that even if you can commercialize your technology within 1 to 5 years, will it really be compatible with the market? For example, if it's 100 times more expensive than the industry is willing to pay, obviously that is not going to be adopted by the oil and gas companies. So the overlying arching issue for this challenge is to reduce trucking, and I think both Ed and Cecilia mentioned how the technology will help do that, and it would behoove you to include a brief statement of how your technology can reduce the trucking of water, fresh water, or produced water, and even sludge within your document in your response. The next criterion is about legal requirements and industry best practice. Now, we understand that some of you that are not in the oil and gas industry may not be familiar with all these, but you can give us some statement about how your technology is eco-friendly. The judges will really be able to evaluate that in more detail. And lastly, of course, as with all challenges, the entrance capabilities and experience will be a major part of the evaluation criteria. You know, some of these criteria, as I said, were such as the legal requirements and all. We understand that you're not going to, all of you are not going to be able to respond to those in a lot of detail. And the goal of this challenge is really to stimulate innovative solutions. So let the judges, the experts decide about the industry practices and the legal requirements. And really I want to encourage everyone who has a good idea or a great technology to submit a response.
Great. So moving on, Al, why should solution providers be interested?
Well, obviously there's the funding. There's $500,000 in funding that's available, $25,000 unrestricted funding to the 5 winners, for the 5 winners, and an additional $375,000 to be distributed to between those technologies. So the judges will decide which of those 5 will receive additional funding, and also really, which may be even more important to a lot of you, is this long-term relationship that you develop with the sponsors.
Great. So now we're going to move on to our frequently asked questions. While we have, oh, I apologize. I totally cut Al off. Continue going. I apologize for that, everybody.
One of the main issues that we always address is the IP issues. So we want to remind everyone that by submitting a response, you do not compromise any of your IP. The sponsors do not compromise any of your IP. So you completely retain your IP even though you're responding. We ask that you really insist that you not include any confidential information. If you have any questions about how to submit a non-confidential response that's technically challenging and interesting to the judges, please, I have something on the forum. Go to the forum on the challenge website, and I have a little list of how to write an interesting challenge in a non-confidential response. You can also contact me or contact NineSigma, and they'll put you in touch with me, and I can help you with any specific questions. Obviously, for all of you entrepreneurs out there, the ability to work with large corporations like GE and Statoil to commercialize your technology is incredibly valuable. And you know, being part of this great opportunity to help the oil and gas industry solve their big challenges is very rewarding to respondents.
So now we'll move on to the 5 frequently asked questions. I apologize for that. I misheard what he was saying, and I thought we were further along than we were. So with these next 5 questions, these are things that we typically hear in terms of this challenge and in terms of challenges in general. So we like to get them out of the way and hope that we can answer some of those questions that you might have submitted through the question and answer box. Again, taking this opportunity to have you continue to put your questions into that box so that we can answer them right after this, as it is the next section of this webinar. We have already received a number of really great questions and would love to continue to personally answer these as we move forward. So as we move into this frequently asked questions, the very first one, is it possible to submit videos, YouTube files, etc. with the proposal? Is this option highly recommended, and would that give a higher rating during the evaluation process?
So videos can be very helpful, but only if they're really designed to help the judges understand. If you just put a video in that's long and rambling and not really helpful to the judges, it's not helpful. But one of the winners from the SAND challenge, for example, put together a just phenomenal video that really helped explain the capabilities of their technology, and that was very valuable. But please do not send us a video file. They're just too big for us to move around. So please give us a link to the video file, whether it to wherever it lives on YouTube or your organization's website.
So what level of technology readiness are the sponsors looking for?
Yeah, this is important, and as I've mentioned before, the sponsors are really interested in looking for technologies that can be commercialized within 1 to 5 years. They really want to make an impact, a real impact on the industry. For feasibility studies or prototyping, we're looking for technologies that can be have proof of concept within about 6 to 24 months.
Great, and I know we've already sort of addressed this earlier on, but what about my IP?
Yeah, and this is such an important topic that we wanted to hit it twice. Again, just by submitting a proposal, you are not compromising your IP. The sponsors are not making any claim to your IP. If you have any questions about how to write a non-confidential response, please contact us.
And what is the award structure?
So there will be, so the total prize pool is $500,000, and up to 5 winners will be selected. Each of those 5 winners will receive $25,000 unrestricted award, and all those 5 are then entered into a pool to be distributed of $375,000 for further development. So the judges will make a decision as to how to divide that money between the initial winners. And then, of course, it could also lead into a longer-term relationship with the client.
And will I receive a detailed review of my proposal if it is not selected?
No. So unfortunately, just due to the number of responses and the fact that clients are not granting agencies, you will be notified about the status of your proposal, but you will not receive a detailed analysis of why. So you will not receive detailed feedback.
Great. So now we're going to go ahead and move into the live Q&A portion of the webinar. We're going to go ahead and open the session up to the questions from the audience. Like I said, we've already received a number of great ones. Please continue to submit those questions through the Q&A chat box. And then we're going to go ahead and take the rest of this time to answer them live. If we don't get to your question, don't worry. Our Q&A session is being archived, and all questions and answers will be made available on the challenge site following this webinar. Just another quick reminder that it is being recorded, it will be transcribed, and then all of that information will be put up on the challenge webinar as well as sent to all of the registrants of this webinar. So another reminder as well, feel free to continue to keep live tweeting any of the facts that you hear, especially during this Q&A portion. Just use the hashtags that you see on the bottom of the slide, and any of the handles such as @9sigma, @GE_oil and gas, and @StatOilASA. So here's a slide just to remind you of who you're going to be speaking to during this session. And let me go ahead and make sure that Cecilia and Ed are all ready to go. So you both are unmuted at this point. You can just volley back and forth. So the very first question that we received is, really quickly, what is the average temperature of the water when it comes out of the water pipe after the drilling?
Sorry, I didn't quite catch that question. Could you repeat it, please?
Not a problem. What is the average temperature of the water when it comes out of the water pipe after the drilling?
So after the drilling, I guess what what this means is after the hydraulic fracturing, because that's when the water starts to flow back, and it really depends on where you are in the well. I mean, we're down to the bottom of the well can be up down to 10,000 feet, and then from the point that the water starts moving horizontal and up the vertical well and up to the top side, it will drop quite substantially in temperature. So it's hard to give an answer that will cover all wells, but typically it would be approximately at 250 Fahrenheit on the bottom, and then you would probably be somewhere between 50 and 100 Fahrenheit when it gets to the top. So it will have a gradient temperature drop from the bottom to the top.
Great, thank you so much, Cecilia. So we had a question asking about, I think, a little bit more clarity around the oil and grease content and how you're looking to reduce those levels.
Do you want to answer that, Ed, or?
Sure. You know, I mean, we have what data that we have on what the oil and grease levels are. It's desirable. It really depends upon the intended reuse or beneficial reuse that might be proposed. Obviously, some will require, basically, if it was to be for drinking water, then basically all the oil and grease needs to be gone. For other uses, you know, getting it down below a part per million or 10 parts per million for hydraulic fracturing use might be quite acceptable. So it's going to vary. And I mean, the data we have is the data that we have that's available to everybody that's on the table. And again, that shows the range of what we know is in there right now. But yeah, I know it's a terrible answer, but it depends on what the intended use of the water is with the treatment system.
Yeah, and maybe I can add to that. Also, you know, today we are mainly disposing the water in injection wells, so we're not actively measuring the oil and grease for reuse. So Ed is very right in what he says, that it really depends on what you are reusing it for.
So would you say that if you're going to respond to that question, that you should qualify your answer by saying it would be applicable, whatever level you're able to achieve would be applicable for either drinking water or for agricultural use or whatever?
Yeah, and that's right, and for hydraulic fracturing. And as you mentioned too, Al, earlier, there's regulatory considerations also that would go with each potential beneficial use that need to be considered as within the framework of the proposal.
Great. So we'll go ahead and move on to our third question. How do you define energy efficient as compared to what? And then they have the suggestion of distillation.
Well, what you're usually doing, it's the unit of energy that you use per unit volume of the water that's being processed. So, I don't know that there's a clear answer to that. Typically, in the field, we're either using the kilowatt hours or the BTUs that are needed to process a unit volume of the water, be it a barrel or a cubic meter or whatever measure that you're going to use. I mean, that's pretty much what's typical in the field. And different treatment methodologies have different energy efficiencies. And our goal is to be as energy efficient as we can.
Great, thank you so much, Ed. So moving on, what is considered cost-effective dollars per barrel?
That's a good question, but it depends upon what's being taken out. And it depends if you're, it depends also on the water quality, initial water quality that you have to begin with. A lot of methods now are getting down below $3 a barrel range. Our goal, everyone's goal, is to bring treatment costs down as much as you can. Again, what your overall cost might be might also depend upon whether you can recover any valuable products from the treatment process itself that would be marketable. So in considering the overall economics, you need to take into account all the factors that we've tried to enumerate on the initial slide there. There's no, I think, set answer. Someone might tell you, yeah, I want about 50 cents a barrel, but that's in reality, that's probably not achievable unless you have pretty clean water to begin with. And obviously we do not. So the challenge of that is that there's a range of water quality to begin with, so the actual answer to that is probably going to be variable also.
Yeah, and just to add to that, I think it's also to look this into a perspective of, what, as Ed mentioned, what is the treatment technology doing and how does it affect the amount of fresh water we could avoid trucking on site, and also the amount of wastewater we would avoid injecting in disposal wells. So it's really hard to give a specific number on that. We would have to look at it as a whole.
So I just wanted to kind of frame that for trying to respond. So would you say that they should just explain their rationale for why they think their technology is valuable to GE and Statoil?
Absolutely, Al. No, yeah. That's fine, Al. I mean, people should have a rough estimate of what their the overall cost of the system might be, and they'll need obviously to consider again how much energy that it takes, because that's usually what the biggest cost is.
Okay.
Great. So, what kind of volumetric flow are we talking about?
Well, we've set a range in here, I think, from anywhere was 50 to 1,500 barrels a day is what are our initial. I mean, we'd be willing to look at it. It should be at least meet the minimum. If something is going to be able to, the system is going to be able to treat more than 1,500 barrels a day, that would be a good thing, and certainly would be a consideration in the evaluation and judging. But we pretty much said it's got to be at least 50 barrels a day. The more you can do, the better it would be.
Yeah, and just to add to that, I think you know, as when you're on a well pad and fracturing a well, the volumes of water flowing back in the flowback period will be a lot larger than after you know, a few weeks. The volumes will drop quite substantially. So it would need to be able to handle the volumes would differ from that flowback period to when you're over in a more production phase where the volumes are smaller.
Yeah, and as Cecile mentioned, you know, usually it depends upon, you know, the particular well and what the geologic and hydrogeologic characteristics are. But after some point in time, it may take a month, it may take 2 or 3 months for some wells, the production volume that will come up will stabilize. And it would be useful to indicate whether, you know, what the volume requirements, you know, or volume capacity, I should say, of the system will be. As Cecile mentioned again, you know, following hydraulic fracturing, you have a large volume of water initially, but that water is generally much fresher because it takes time for the water to equilibrate because the water we're putting down is generally somewhat fresher to begin with, and the salt creeps in over time, as do the divalent ions and other constituents that are dissolved from the formation. So this is one of the things that, you know, a smart water treatment system that was tied to real-time analytical would be useful if somebody can do that. But again, you know, the volume requirements, they do vary over time, and they will vary from well to well. If the proposal was just not to handle hydraulic fracturing water, but just stabilized, equilibrated, produced water, you know, that people can do that, and that would be part of the challenge, but probably not all of it.
Great, thank you so much. So we have a question on how many feet of the whole pipe does the halite gather on? I.e., is it the bottom 6 feet, or an example of that?
So there is no single answer on that, but what we see is that we have seen halite issues as low as 4,000 feet and all the way up to the top side. Sometimes we only see the issues top side. Sometimes in the wellhead, or somewhere in between those 4,000 feet and up to the surface. So it's somewhere in between there the issues are.
Sure, great. So we have a question on a slide, so I'm going to go ahead and refer to that slide so that we can actually, okay. So referring to the slide where we want to solve, there's an individual who has a prediction tool that can accurately calculate solubilities of the mentioned systems. This also indicates that they can predict which additional ions could be helped in dissolving halite. Would this be of interest to this challenge?
So when it comes to prediction tools, we are already using these quite actively internally in both, as far as I know, in GEL as well, and in Statoil. If there are technologies which comes to additives that could be added to increase the solubility of halite, that would be something that would be of interest.
Great, thank you, Cecilia. Question is, can we assume that gas that would otherwise be flared will be available?
So do you want me to answer that one, Ed?
Yeah, I think you know the operations a little better than
Yeah.
I.
Okay. So so what you know, our company is actively working on how we can reduce the amount of gas being flared, and it will of course depend on which pad you are on, and if there is flare gas available. But in general, you can assume that there will be enough. If you were able to transform that flare gas to power, there will be a sufficient amount of flare gas available. Yes.
Well, yeah, let me just add to that, Cecilia. You know, and we've seen a lot of proposals such as this in the past, and usually I recommend people, you know, the flare gas is maybe there initially, but the amount goes down over time. So I would not want to base my economics on the possibility. I mean, that's an added part that we can put to everybody, but my recommendation to people would be to put a value on the gas and just assign that when they do their overall economics. The other issue I would tell people is the typically early gas, flare gas, is not necessarily of pipeline quality. And I know a lot of people have tried to use that for their treatment system, and they had a lot of disruptions and failures in their system because of the quality of the gas can be variable. So my recommendation to people is you could consider that, but don't base what you're giving to on the use of quote unquote free gas. I found that, and I've been doing this for a number of years, that's not a good way to go. You should just put everything. In fact, for the efficiency of judging, it would be useful if everybody just put an assumed value for gas in there. I think that would be a better way to do that.
Great, thank you so much, Ed and Celia. So we are rounding out. We have time for just one more question. I want to remind everybody, though, that your questions will be answered no matter what. So feel free to continue to have them or more come up last question here. But we do want to give enough time at the end to provide that information on what you can do today. So this last question is, what are your top 3 biggest pain points in trying to reduce water usage in drilling?
Either Ed or Cecilia, I think I'll let you take those.
Well, I'd let Cecilia's operation. I think she should go first.
Yeah, I think I needed to repeat that because the audio was not working for me here.
Okay, sure. So what are your top 3 biggest pain points in trying to reduce water usage in drilling?
So just to emphasize, it's not drilling where we have the water use. It's when we hydraulic fracture a well, and it's during production when we experience halite deposition in our wells and have to use the fresh water to dissolve this halite. So I'm not sure that I just want to make this clear. It's not during the drilling that we're using. That's not the pain point of the freshwater use.
Thanks. That's really great to differentiate those two. But the pain points that I would say are really well described in the statement. So I think we want to really focus, regardless of what all the pain points might be. I think the challenge is really focused very specifically on the 2 focus areas that Ed and Cecilia described in their slides.
Great. So we are just rounding out to the 11 o'clock hour, so I'm going to go ahead and move forward. Again, I will reiterate, if you have additional questions, please feel free to continue to put them into the question and answer box, and we will have them collected and answered within the actual transcription of this webinar as well. We've already received a number of them that we weren't able to get to live, so please be reassured that everything will be actually answered, even if it was not answered verbally through the webinar. So what can you do today? Of course, you want to visit the challenge website, which is www.poweringcollaboration.com. Once you're there, register to receive updates, view the FAQs, and join the community. You're going to want to stay connected via that community forum. That is the place that we were talking about where all of this information will be actually live for you as well. If you're on this call, though, don't worry, you will be actually emailed that as well. But this is a great additional place for you to get more information on top of this recording and the transcription. And then if you have any questions, please contact the Grand Challenge desk, which by email is grandchallenge@ninesigma.com. And then by phone, it's 216-283-3901. And then finally, obviously, submit your proposal. The deadline for submissions is, again, we're going to reiterate it, September 24th, 2015 at 5 p.m. Eastern Daylight Time. Very important. If it does not get in before then, it is not valid. So, go ahead.
And I just want to encourage you again to go in and at least fill out part one. It will just take you a few minutes.
Sure. So that, again, concludes our webinar for this morning. For additional information, again, I encourage you to go to that community forum on the challenge website. One last reminder that this is recorded and that it will be made available both on that forum and also through email to the registrants of this webinar. We're going to go ahead and thank you again for attending, and then also to our speakers for their time and expertise. We appreciate everybody's time, and we really look forward to receiving your submissions. Thank you again, and have a great day.